Once the Q&A is over, we will post a link to the assessment in the chat box. All the participants who are attending this can access the link to that assessment. And this would be based on today's webinar. This assessment would be based on today's webinar. So those who are interested in taking the assessment, I would request all of you to stay connected and to listen to the speaker fully. It would be based entirely on the content that he will be delivering over the next 45 minutes or 1 hour. The link to the assessment will be kept open for 60 minutes only post the webinar, and it will also be followed by webinar feedback. This would be about 3 or 4 questions, qualitative questions that we would like your observations on about how we delivered this webinar and how you think we can improve. We request you to please use a Gmail ID to take the assessment, preferably as this assessment is through Google Forms. And participants who get 6 or more answers correct out of 10 would be eligible for the award of a certificate. I repeat, participants who get 6 or more answers correct out of 10 questions which appear in the assessment would be eligible for the award of a certificate. It is now time for me to introduce our speaker for today, Mr. Sandesh Anand. Sandesh Mysore Anand is a seasoned information security professional with over 12 years of relevant experience. He is currently working as Senior Engineering Manager Information Security at Razorpay Corporation in Bangalore, managing Razorpay's security program. Sandesh is also the author of Boring AppSec, which is an infrequent newsletter on application security. And in his spare time, he enjoys spending time with his young family, running and trying out street food from all over. Sandesh received a BE in Computer Science and Engineering from Visvesvaraya Technological University in 2007 and an MS in Computer Science from the George Washington University at Washington, D.C. in 2009. He also holds a graduate certificate in public policy, specializing in public policy analysis from the Takshashila Institution, which is a premier Bangalore-based think tank, which he completed in 2014. Now I request Sandesh to please share his presentation. So as a control room, I request you to please unmute Sandesh.
Okay, great. Can you hear me, Abhishek?
Yeah, Sandesh, I can hear you.
Okay, excellent. Hey, thank you so much for the kind introduction, and thank you for inviting me to this webinar. I have a little bit of a cold, so apologies if I'm kind of coughing or sniffling through the presentation. Like was mentioned, this presentation is set to last anywhere between 40 and 45 minutes. I would really like it if the session is interactive, so you can do the Q&A at the end, but at the same time, if you have any questions in the meantime, please feel free to put in the chat box. I'll try my best to answer it. At the same time, like I said, I plan to be interactive, so there may be some questions that come up as part of the presentation. Please feel free to answer those as well. So with that brief introduction, let me get started. So I think I'll not go through this because I think there's already been a great job done at introducing me. Okay, so what's on the agenda today, right? So I think first thing we will definitely talk about what is application security and why is it important. Okay, why should you even worry about it? Is it something that is useful for you as students in your career? Right, I think that's kind of the thing I want to focus on, and we'll give a few examples for that. Next, I want to introduce you to something called OWASP. Okay, OWASP, I'll talk more about it, but the reason I want to talk about this a little bit is that it's a phenomenal learning resource. No matter how much we talk about application security, we can't complete any content in 45 minutes, right? It's a very vast area. So what I want to do instead is to point you to some very useful resources on the OWASP, on the OWASP website, which will help you in your journey going forward. So that whether it is, in the next few weeks or the next few months or the next few years, if you ever want to learn more, you have a starting point on where to start learning from. So we'll talk a little bit about OWASP. Finally, to give you a flavor of certain kinds of vulnerabilities, we'll focus on 3 different vulnerability areas: injection, sensitive information leakage, and broken access control. For each of these, we will talk a little bit about what these vulnerabilities are, how to remediate them, how to make sure your applications don't have them. This is broadly the agenda for the day. As mentioned, please feel free to be interactive. Ask your questions on chat, or even if you have any thoughts, please feel free to put it there, and we'll have Q&A in the end. Okay. So let me go to the next slide. So what is application security and why is it important? So before I define application security, I want all of you, I'm assuming all of you are familiar with some amount of C code, right? I want you to all read this line of code that you see on the left, right? There are 12 lines of code here, okay? And can you tell me in the chat box, okay? Or you can unmute, I think you cannot unmute yourself, but if you can chat in the chat box, if you can tell me which of these line may have a security bug. You can take a guess. If you're not sure, that's okay. I'll give maybe 30 seconds for you to look at the code and think about it, okay? So 30 seconds, please enter your answer in the chat box. And if you can also answer why you think it is that line, even better. Abhishek, they'll be able to type in the chat box, right?
Yes, Sandesh. Yeah, they will be able to do that.
Okay. I'm trying to see the chat box if there are any answers so far. 12th line. Okay. Thank you, Jyoti. Okay, I'll maybe give 10 more seconds for people to try again. I think Jyoti has done one attempt. 12, Raghavendra, thank you. Okay, so I think Jyoti and Raghavendra both got the answer correct. The answer is in line number 12. Let's dig a little. Let's go a little deeper and try to understand what happened here. Okay, so this vulnerability is a very common. Thank you, Sneha. You're right. Right. So this vulnerability is a very popular vulnerability called the heartbleed vulnerability. Okay. So if all of you have learned some C programming in your college, you would have learned that there's something called memcopy, or basically allocating dynamic memory, right? So in this case, what happens is there is a open source project called OpenSSL, okay, which is used almost by every company in the world. Okay, so in this, what is happening is that an attacker is able to basically send a small payload. Okay, they'll send a small payload as well as mention what is the size of the payload. It's like saying, I am sending you a package. In that package, there are 12 fruits. Okay, so I'm saying package, and then I'm saying there are 12 fruits. I'm describing that. And then what the other person is supposed to do is respond to you, saying, okay, I acknowledge that you are asking for 12 fruits, and here it is back. So this is called usually a this is basically to check if the server is alive. Okay, if the server is gone down or not. So the client sends a message to the server responds with the same message to make sure that the server is alive. Okay, it's called a heartbeat message. So in this case, what an attacker was able to do was, because the server was not verifying what is the size of the package, it was assuming, because I am saying there are 12 fruits, server is assuming there are 12 fruits. Because of that, the client, or in this case the attacker, is able to exploit the server. What they're able to do is they're able to send only 10 fruits, but say the size of my fruits are 100. Okay, so I'm just giving an example, of course. So in this case, what is happening is that, like you can see here, when the memcopy function happens, right, instead of copying only the 10 bytes, it's copying 100 bytes from memory. Okay, which means that instead of sending just what was sent by the client, the server is actually sending additional data from its memory. Okay, this is classically called a buffer overflow attack. Okay, and when this happens, what happens is that the client can actually steal data from the server, right? And now this may feel like a very small thing, right? They can say, hey, what is the big deal? It's only a few bits of data. But imagine if you can write a Python script, right, to do this over and over again in a loop for, let's say, 1,000 times or 10,000 times, right? So then what ends up happening is that you can read everything that is in the server's memory. Okay, and if you can do that over and over again, as you may know, in your computer or your server's memory, a lot of sensitive data is stored. This may be encryption keys, this may be your passwords, this may and etc. etc. So when this vulnerability was discovered, right, almost every company in the world had to panic, right, and they had to upgrade their software quickly. The reason I'm talking about this is that if you look at this code, right, sure, it is a small mistake, but it doesn't, it is the kind of mistake that every developer may make, right? It appears when you're writing code that this is not such a big deal, right? But the consequences of writing insecure code is massive, right? So that is the reason I wanted to show you this as an example, right? That if you don't build your applications in a secure manner, if you don't write code in a secure manner, it can have disastrous consequences on the security of your application as well as for your organization. So with that example in place, I want to quickly define what is application security. Okay, so application security is basically the use of tools and processes to secure application across their software development lifecycle. So let's start from the end. What is the software development lifecycle? All of you must have heard of different ways of building software, right? The waterfall method, agile methodology, and so on and so forth, right? So irrespective of what software development lifecycle you use, the idea is that across the lifecycle, you should use certain processes and tools um, to make sure that the applications are built in a secure manner. And sorry, and if the applications are not built in a secure manner, then you should make sure that you discover these vulnerabilities early. Okay, and once you discover them, you should fix them, right? That is the whole that in a nutshell is the concept of application security. Now if you think about companies like Razorpay, where I work, right, we build what is called payment gateway. So when you go to a website and you make a payment, you go through something called a payment gateway. Many of you may have used Razorpay with or without your knowledge, right? So the idea is that if and tens of lakhs of websites in India use Razorpay today. If we make mistakes in our applications and we introduce security vulnerabilities by mistake, then that affects not just Razorpay, but so many different merchants. That is why application security and making sure that applications are built securely is very important for a company like Razorpay. And I'm sure it's no different for other companies which are building software as well. So whether you are a company which builds software, whether you are a government which is trying to build software for the benefit of the public, whether you are, let's say, the income tax department, which has the difficult job of making sure people can file their taxes online, all of these organizations need to make sure that their applications are built in a secure manner. Okay, so now we have seen an example of how insecure code can create damage. We have also defined application security. How do we do this, right? What are some of the tools and processes we can use to perform application security? So I spoke about software development lifecycle, right? So let me walk you through this diagram that I have. Okay, so in general, every application feature which is developed, right, it usually starts with some kind of documentation. Some of you may call it a requirements document. Some of you may call it a technical specification. Some of you may call it, with various other names. And once you write the document, a developer will probably have to write some source code on their laptop, okay, on their local environment. After that is done, they usually push that code to a centralized code repository. These days, Git-based repositories are very popular. So GitHub, GitLab, Bitbucket, one of these you will push it to. And finally, you deploy it to a server. Okay. Like I said, these days, most of the deployments happen on the cloud, on a cloud service provider like AWS, Azure, Google Cloud, etc. And usually, there's a process of containerization before you deploy. Now, I'll not go into the details of cloud and containers, etc. All you need to know is the lifecycle of an application is you come up with the requirements, you write code in your local machine, you send the code to a central code repository, and you deploy that code onto an infrastructure. All right. This is the 4 high-level steps of any software development. Now, what is important in terms of secure development or application security is that in each phase, you perform certain security activities. Okay. So in the phase of design or in the phase of requirements gathering, you should do something called a threat model. Okay, please pay attention to all these terms. It will be useful during your evaluation. Right? In threat modeling, what happens is that you look at the design of your application and see, if there are any security flaws or vulnerabilities. For example, if you are building a new login page for your application, you want to make sure that this login page requires a username, a password, and an OTP, for example. Okay, now if it doesn't have an OTP, then you're leaving a security vulnerability open. Okay, you might have seen in many banking websites or other websites where without OTP and password you cannot log in. So that is the example of a threat model, sometimes also called a design review. Okay, second is what's called a code review or a static application security testing. So here what happens is that for the code you write on your, as a developer on your machine, you will basically use certain tools to see if you've made a mistake. Now, for example, when you write code in the IDE, right, if you, let's say, use the wrong syntax, what will the compiler do, or what will the IDE do? It will give you like an error message saying, hey, you have not added a semicolon, or this is an integer but you're assigning it to a character, and so on and so forth. Similarly, there are tools which can help you tell you if the code you've written is insecure. Okay, we'll talk about some examples in the future. So for example, we'll talk about some real life examples later, but in the example of Heartbleed, if the IDE itself told you right there that, hey, you're doing an mem copy but you're doing it in an insecure manner, it would be very simple to fix it. Okay, that is called code review on the developer machine. Then when you check in the code into your code repository like GitHub or GitLab, you should do a static analysis, which is a code review, as well as something called a software composition analysis. What does that mean? Okay, so let's take a step back. How do all of us write code? One is we obviously write our own source code, but more and more with the increase in usage of open source, we leverage code already written by other people in our applications. Okay, so what we do is that, for example, let's say I'm building an application to analyze log files. Okay, and I want some function which will convert the log file into a CSV, so I can go read it. Okay, there are plenty of open people who have already written the code to convert logs into CSV. So instead of rewriting that code, what we will do is we'll import that library and then use it in our code. Now, what if that library has an insecurity, right? Detecting that is the job of software composition analysis tools. Okay, so when you check in code to your repository, you can do a combination of static analysis, which is code review, as well as software composition analysis, sometimes also called open source scanning. Okay, so that is done here. Finally, when you deploy the application, you can do many different things. Okay, one is container scanning, but we'll not talk about that today. That's a topic for a different day. And there's another aspect called penetration testing. Penetration testing is where you must have heard of user testing or quality assurance, QA testing, etc., where a tester is trying to see if the application is working as expected. Okay, but a penetration tester is trying to test the application from a perspective of security. So, for example, if there's a authentication login feature, a QA tester will say, hey, if I enter the right username and the right password, will I be able to log in? That is the job of the QA tester. What will a pen tester do? Pen tester will think, is there a way I can log into this application without a password? Okay, can I bypass the authentication? If I can do that, that means I can access sensitive data of other users. I can impersonate other users, and so on and so forth. Right? This process is called penetration testing. I think somebody asked, how can I test from the outside? This is a very good way to test from the outside. In fact, if you are doing a penetration testing with no knowledge of the application, right, of how the application is built, of the source code, of the requirements document, then it's usually called a black box penetration testing. On the other hand, if you have all this information, then it's usually called a white box penetration test. Something to keep in mind for the evaluation later. Okay, so like I mentioned, quick recap. Secure development happens in a life cycle. At each stage of the life cycle, you should think about security. That, in a nutshell, is application security. So the one other advantage of doing application security this way, actually, let me tell you a story, right? When I started working in security about 10 or 12 years ago, right, all these steps did not exist, right? Most people only did penetration testing. which was at the end of the life cycle. So what you would do is you would spend time writing requirements, designing the applications, writing the code, deploying the code. Then you will do pen testing and find the vulnerabilities. Now you have to again do everything again to fix it, right? Whereas today in modern companies and modern application systems, what people do is they try to find vulnerabilities early. That way, it is simpler and cheaper to fix these vulnerabilities, right? So secure development is important so that you can reduce the cost of fixing defects, and obviously it will reduce security incidents from happening. I see a question about reversing. I'll talk about that later. I think it's a little off topic, but we'll talk about it in the Q&A. Okay, great. So now, a lot of what I must have told must have been overwhelming for you. I'm sure you understood some parts, but some parts, may have gone over your head, or maybe I speak too fast, right? So what I wanted to leave you with is a few resources which will help you learn about application security even after this webinar, okay, where you can go and talk about it. So before I start, I want to introduce you to something called OWASP, OWASP, okay. Now OWASP is a foundation, okay. It stands for Open Web Application Security Project, okay. So when I was doing my master's in George Washington University, I had a course on e-commerce security, okay, where we were thinking about how to secure e-commerce application. And when my professor at that point had basically said, hey, there's a group called OWASP. They have an annual conference every year, and there are 2 free passes available for people who are willing to volunteer, who are willing to go, help organize the conference, attend the events, and help with all the organization. So I said, I didn't know what this was. I had never heard of it. I said, okay, I will go and I will maybe help people out. It'll also be a good chance to meet people in security. So let me go. So I spent 2 days, with the conference organized by OWASP, and it completely changed my career. Okay, why? Because I did not know something called application security existed, and I did not know that there was a group which solely focused on application security and built many resources to help people learn more about application security. And since then, in every job I've had, I have used various OWASP resources. Okay, so what is OWASP? Okay, OWASP is first of all a powerful community. Okay, there are thousands, if not hundreds of lakhs of AppSec professionals across the world. OWASP finds a way to connect all of them. Okay, they do it through local chapters. For example, in Bangalore, there's an OWASP chapter. In Delhi, there is, and so on and so forth. And pretty much in every big city in the world where security is important, people use there is a OWASP chapter. In addition, there are many open source projects that OWASP supports, which helps you learn more about application security. And we'll talk about 2 of those in the future slides. Finally, every year, OWASP has a bunch of conferences where you can attend, and you can either participate as a speaker, you can participate as in their workshops, or also be a presenter going forward. I have been very fortunate to attend some of these conferences, and they have been very useful. Okay, so let's talk a little bit about one very important OWASP project. Okay, so one of the most popular OWASP project is called the OWASP Top 10 project. Okay, what OWASP does is that once every 2 or 3 years, they create an awareness document on the most critical security risks to web applications. Okay, I want to be clear. This is only the top 10 most critical. This doesn't mean that these are the only 10 things that you have to worry about. Okay, but these are the top 10 most critical. Okay, and they have a separate list for web applications, for APIs, and for mobile applications. Okay, and if you want to start learning about application security, then these 10 are a great place to start, okay, your journey. So if any of you at the end of this webinar are interested more about learning about application security, then I would highly urge you to go to the OWASP website, go to the top 10 project, and learn more about each of these. It's a great way to start. There are also many hands-on labs that you can practice in the OWASP website. And we'll talk in depth about a few of these OWASP top 10 in the next few minutes. Okay, the next OWASP project I want to talk to you about is called the OWASP Cheat Sheet Project. Okay, like you can see, it has some, obviously as students you should not cheat, but the idea of cheat sheet project is to make it to create a single place for various kinds of application security topics. Okay, so for example, if you have a question of saying, hey, how do I do encryption? Okay, or how do I do hashing? Right? There's a cheat sheet for that. If you have a question about how do I implement OTP, there is a cheat sheet for that. If you have a question on, let's say, how do we perform input validation, there's a cheat sheet for that, right? So what happens is that in addition to just talking about vulnerabilities, the OWASP cheat sheet series also tells you how to implement securely, right? And that is why it's one of my favorite favorite go-to resources as well. So be sure to check this out as well after this webinar. Okay, I think we have 15 minutes remaining, so I will try and deep dive into 2 or 3 different areas or 2 or 3 different vulnerabilities within the OWASP top 10. Okay, so this is a little cartoon which is sorry, which is very popular. So the first one I want to talk about is something called injection attacks. Okay, so what is injection attack, right? So whenever if you've ever built application, you'll routinely receive input, correct? You receive input from the user. Now, when you receive input from the user, you expect data. So for example, if there's a field called name, you expect me to put in Sandesh. If there is a name called field called designation, you expect me to put engineering manager or something like that, right? But what happens if instead of name as Sandesh, I put something like what is there here, right? I say Sandesh colon drop table students. Okay, so what would happen here, right? Now, if you understand how applications are built in the back end, anytime I take input, right, it is usually validated against a database. Okay, so if you carefully craft your input in such a way that it can confuse the application to doing something more than just displaying your name, that is usually called an injection attack. So you're expecting to receive some data, but the end user actually sends some code, right? That is at a very high level what is an injection attack. So let me give you an example. Okay, so here is a query. Okay, I hope all of you understand a little bit of SQL queries. So here it says select ID from users where username equal to user and password equal to password. Correct. Now, bear in mind in this code, user, this variable called user and this variable called pass, it's coming from the client or in the end user. So for example, assume there's a login screen somewhere. In that you enter username, that goes into this user variable. You enter a password, that goes into this password variable. Okay, this is a fairly typical implementation. Now, most users will put username as their username, password as their password. If it's correct, they'll log in. If it's not correct, they'll not log in. Now, what if you're an attacker and you want to bypass the password, right? So what if, for example, I want to log in as, say, Akash, who's on this webinar, right? But I don't know Akash's password, right? So how do I bypass authentication? Okay. So what I can do here is I can enter Akash's username as Akash in the form. Okay. But instead of password, I will actually put this payload. Okay. It says password quote or 5 equals 5. Right. Now, all of you who have learned some SQL queries will know 5 equals 5 is a comparison, which always results in 1. Okay. Because 5 equal to 5 is true. So that is 1. And then password is just a single quote. So this is false. So false or true is always true, right? Now, because of that, what happens is that this query becomes select ID from user where username equal to Akash and true. Okay. Now, as long as there is a username called Akash, it will actually clear the query, even though I have not entered the right password. Okay. So this is obviously very bad because using this, you can actually sometimes bypass login. You can steal data from a database that you don't have access for, and so on and so forth. This kind of injection is called a SQL injection, right? Where you're using injection to either steal data or bypass controls from SQL queries or from databases. So how do I fix this vulnerability, right? So some of you may have heard of a technique called parameterized queries. Sorry. So I will not dive too deep into this. This is something you can look up later. But essentially what it does is that it makes sure that the password you apply, right, is not treated as code, but as data only. So for example, if you put the payload as password or 5 equal to 5, instead of resolving this logical statement, it will see if there is a password called or 5 equals 5. Okay, so that will make sure that this logical resolution does not happen, and therefore injection does not occur. Like I said, if this was not clear, I'm happy to repeat it later, or you should definitely Google parameterized queries. You will find plenty of resources on OWASP and other websites which will help you understand this very important concept. I would urge all of you to pay attention to this and make sure you understand it. Okay, so I gave you an example of SQL injection attacks, but there are many other kinds of injection attacks, right? The most dangerous of them is called a command injection or a OS injection attack. Here, on behalf of the server, you can run some OS commands, okay? And that means, for example, you can run command like exec, right? Which will basically, execute any command on your behalf. You can also steal data and exfiltrate it to a third-party server, which is obviously very dangerous. You can also do injection on XML. So if you're uploading XML data, you can inject certain payloads and much more, right? The interesting thing is injection attacks have been on the OWASP top 10 since OWASP started. That is since 2005 or 2007, I believe, right? So though the world has known about injection attacks for 15 years, it still goes on. What does that tell you? It tells you, one, it's a very deadly attack, and two, it is very difficult to remediate at scale. In theory, everybody knows how to remediate it, but at scale, it is actually pretty difficult to remediate. Okay, so what are at a high level techniques to protect against injection attacks? So one is input validation. So what does that mean? Every time you receive data from a client or from a third-party source, you should always validate it. Okay. For example, if you build a web form, if you build a Google form, or if you build a web application where there's a form and there's a field called phone number, then you should make sure that the phone number only has digits and not letters. Okay. That will automatically mean some of the payloads that I spoke about will not be useful. So that's input validation. Second is a process called output encoding. Okay, what this essentially does is that it makes sure that before you send data to a third-party system like a database or a browser, it encodes the data in such a way that it is not harmful. Okay, so when we use parameterized queries in this example, though dangerous data was sent, it did not create any harm to the database. That's why it's called output encoding. Okay. And finally, use secure by default functions like parameterized queries. Okay, second, we will talk about sensitive data exposure. We'll talk about sensitive data exposure. So if you look at this infographic, you will see that there are many company names here. There's things like Facebook, there's Indian Citizens, there is Capital One, which is a bank, there's Shanghai Police, Microsoft, etc. So what are all these bubbles telling you? These are basically telling you these are the different data breaches that have happened since 2019. Okay, and the number here tells you the number of records of data that has been breached. So sensitive data leakage is among the most dangerous attacks that can happen on a system, and no system or company or organization is immune to these attacks, from the largest companies to the smallest companies, right? And that is why it's very important to ensure that your application is resilient towards data breaches. So how do they happen? How does sensitive data leakage or sensitive information leakage happen? One is by exploiting bugs in your application, right? Like SQL injection I spoke to you about, or an authorization bypass, and so on and so forth. Second is because of insecure configuration, which means that your cloud infrastructure may be configured in a manner that makes it easy to steal sensitive data. And finally, using techniques like phishing, which will allow you to take over people's accounts. So for example, I will install a malware on somebody's laptop, using which I steal all the passwords stored in your Chrome history or in your Chrome password manager, and using that I log into your account, right? So this is how I can steal sensitive data. So like I said, there are multiple ways to steal sensitive data. How to fix them? Okay, there's no one or two ways to fix them. It is very difficult, right? But there are some techniques you can use, right? I'll not go into details because we have only another 5 minutes and I want to leave it open for questions as well. But the first step is to identify where in your application sensitive data is stored. Okay, is it stored in a database? Is it stored in file systems, and so on and so forth? And then enforce a principle called least privileges. What this means is that only people who absolutely need access to a particular system should be given access to that system. So everybody should not be given, for example, admin access, and so on and so forth. Next, you should avoid plain text storage, okay? And you should store sensitive data in an encrypted manner, or you should hash them. For example, passwords should always be hashed, and they should be hashed using secure algorithms like SHA-256. And you should not use insecure algorithms like MD5. Okay, something to remember for your assessment later. And finally, you should transmit data over secure channels like TLS or SSL, as you may have heard, right? And these are the different ways to to handle sensitive information leakage. Okay, finally, I want to talk very quickly about broken access control. Okay, so this is a very popular comic strip that you may have seen. If you have ever used Unix machines or Linux machines, you will see that the joke is always that you type some command, it says you cannot do it, then you say sudo the same command and it works, right? Obviously, this is a bit tongue-in-cheek and a bit jokey, but the idea here is that access control or bypassing authentication is one of the most common ways to bypass security in applications. Okay, so what is access control? Access control is basically a way to enforce policy in such a way that users cannot access, cannot perform actions outside the permissions they have. So if I am, if I'm on a social media network, I should be able to view everybody's profile, but I should not be able to edit everybody's profile. I can only edit my profile. That's access control. Okay, that is the policy and the enforcement of that policy. Okay, so when does access control fail? Access control fails when basically I have either access to read or modify or destroy data that I don't have authorization to. Okay, that's when access control breaks. Right, and this happens to many different kinds of vulnerabilities. Okay, so let's take an example of an API. Okay, very often when you use APIs, you will see that you'll have something called api.something.com/receipts/12345. Okay, if you make that API call, you'll get receipt for order ID number 12345. If you just change it to 12346, you will get somebody else's receipt. Okay, which is obviously very bad because now I know information about what somebody else purchased, right? So this is an example of access control failure, and this happens through many different attacks. Insecure direct object reference is the most common, right? And the other system, question is broken access control restricted to applications only? The answer is no. Broken access control can be an entry point for many different things. Right? Once you kind of, even if the vulnerability is on the application, it can lead to takeover of entire systems, right? In fact, there was a company called, there was a bank called Capital One in the US, where, because of an access control vulnerability, simple vulnerability, the attacker was able to take over vast majority of, not majority, but a vast number of their AWS resources, right? Which is obviously the infrastructure, not just the application. So this is a critical area of application security that you should be aware of. And how can you ensure access control is not broken? One is, like I mentioned in the previous section, deny access by default. By default, nobody should have access to anything, and only people who absolutely need access should have access to it. Second, pay attention to configuration, right? When you, for example, buy a new router, all of you may have seen that there's a default password and none of you have changed it, right? Which means everybody who has that modem usually knows what that password is, right? You should make sure that you don't use default passwords and you make changes, right? Third, conduct access audits, right? Over when you work in companies over a period of time, many different kinds of accesses are provided to people. So every 3 months or 6 months, people perform something called an access audit to make sure that nobody has access that they don't require. Finally, review application code. We spoke about static analysis, pen testing in the past as well, to ensure no loose ends on access control exist. Okay, I think we are on time. So let me end here. And thank you for all of you for listening, and ask if there are any questions for me. I think there are 2 questions on chat. I will answer that first, and then we'll take it from there. So Puneet, how do I detect a fault if I'm outside the organization? Like I mentioned, penetration testing is a good way of doing it. In fact, there's something called bug bounty programs. If you want, you should Google them, where in fact you are paid a bounty for finding bugs on other companies. Okay, only do it with their permission. You should not do this otherwise. And you can use various penetration testing techniques to do that. Next question again from Puneet: how do you stop reverse engineering of applications? Yeah, this is a interesting question. There's a long answer and a short answer. Let me give you the short answer. The short answer is you cannot stop it for sure, Puneet. Right? No matter what protection you use, the moment somebody has access to the binary or the executable, there are many ways to perform reverse engineering. Okay, so you can make it harder for hackers, right? You can make it harder by minifying the application. You can make it harder by encrypting parts of the code, and so on and so forth. But it's really difficult to 100% stop reverse engineering. Okay, so the what you should end up with, basically what you should do is that because of that, you should not store secrets in your applications. You should make sure secrets are stored in secret managers, etc., so that even if somebody reverse engineers an application, they're not able to steal the secrets. They're only able to steal the code, right? So that's something to keep in mind, Puneet. Good questions though. Any other questions from anyone?
Yeah, anyone has any questions that you would like to ask Sandesh, please post them in the chat. Yeah, we have one from TK227 which says, which method is easy to hacking applications?
Honestly, so two things I want to say. Okay, one is that with great power comes great responsibility. So I'm very happy that all of you are thinking about hacking applications, finding fault in applications. It's great for the industry, it's great for career, etc. But you should always do it responsibly. Okay, you should always do it with the permission of the application owner. That is the difference between ethical hackers like you and me and the unethical hackers, right? Who cause a lot of trouble to hospitals, to other systems and so on. So whatever you do, please keep that in mind. Second, which method is the easiest? I don't think there's a single easy method, but I think penetration testing and code review is a good place to start. Any practice tools we suggest for students, Raghavendra, please go to owasp.org. Right, I think there are plenty of tools there that you can go look out, check out. Right, I think there are many tools, there are many cheat sheets, etc. What you can also do, I'm trying to bring that thing up. There's something called OWASP GOAT. Okay, I'm pasting that. Can you still hear me, Abhishek?
Yeah, I can hear you.
Okay. So I've just pasted the link here. There's something called WebGoat. Okay, this is a intentionally vulnerable application, which means it is designed to have security vulnerabilities. And the reason it's designed that way is so that you can practice finding and fixing security vulnerabilities. Okay, so my recommendation to all of you is that go look at Project WebGoat, again from OWASP, and see if you can follow along and learn how to discover and fix vulnerabilities there. It's a very good place to start practicing. Right, Raghavendra, I think this can help you. Pawan is asking me to explain AWS. Pawan, that's a very large concept, right? It is very hard to explain it in a webinar. It requires multiple other webinars. But if I have to put it in a nutshell, AWS stands for Amazon Web Services. And what it essentially does is that in the past, when you had to deploy an applications in some server, you had to have a physical data center, right, where you have to have hardware like a like a computer where you have to go and deploy the application, right? But AWS, what it does is, and that's obviously expensive, right? So for small companies, it becomes very difficult to afford and manage their own data center. But AWS makes it easier for you to deploy applications without the need of managing the data center. So they take care of all the data center stuff, and you can focus on writing your applications. That is essential, in a nutshell, what AWS does. But it's a very simplistic explanation I have given. There's obviously more to it. Okay, any other questions? Name some websites for finding bug and reporting it for our practice. So what you can do, like I said, I think OWASP WebGoat is a good place to start, Mabu. But the other thing you can do is you can sign up for something called HackerOne. Okay, I'm pasting the link here. Okay, so HackerOne, basically what it does is that it allows you to become something called a bug bounty hunter. Okay, so what it does is that there are many companies, including Razorpay, which go and tell on HackerOne that, hey, if you find a security issue in Razorpay or in other companies, you can go report it to those companies through the platform called HackerOne. And if you are a valid report, then people will pay you a bounty. So what you can do, Mehboob, is that you can sign up on HackerOne, figure out which companies will are allowing you to submit bugs, and then you can focus on those companies. uh, Jyoti, you'll have to clarify your question. Which one use tool runtime applications? Contra security. Okay, I know what you're talking about. So Contra security is a tool used which does something called interactive application security testing. Um, Jyoti, I asked is a little bit of an advanced topic. That's why I did not cover that, right? But like I said, right? I mean, I think if you're starting out in application security, I would urge you to focus on static application security testing and pen testing. Those are good places to start. Using tools like Contrast only makes sense once you're an advanced user or you're a large company where you can focus on finding things. That's my opinion at least. Okay, great. Any other questions, folks?
Yeah, any other questions? Please feel free to post them in the chat box.
Okay. Abhishek, should we give a few more? Okay. What does errors in web applications indicate? Very good question, Puneet. That's a really good question. Okay. So let's say you're using a application, okay, and then you input some data, and it throws you an error message and gives you a stack trace. Okay, what does that indicate? So what that indicates essentially, at one level it just tells you that, hey, something went wrong, because of which an error message was given. But if you look at that error message carefully, it can tell you a lot more about the application and the server. For example, if it gives you an error message which tells you that, hey, exception thrown in something.java line number 36, and then exception thrown in SQL java.sql, etc., etc., that basically means that A, the application was written in Java. 2, it is using a SQL MySQL database, and 3, it was not it is not handling errors properly. So Puneet, while just looking at the error message, while just the fact that some error was thrown doesn't mean that there's a security problem, it means there is a possibility of a security problem. Also, when you see errors which are things like stack trace in an application, that gives you a lot of data to dive deeper on other things that can be wrong with the application. Okay, so I think if you want to be a penetration tester, when you see error messages which are very descriptive in an application, that's an indication to say, hey, maybe there is something wrong here, and something I can explore. On the other hand, if you're a developer and trying to build application, you must make sure that your error messages are useful for the end user, but at the same time does not reveal too much internal information, right? So it's okay to say, hey, the page you're trying to access does not exist, right? That's okay. That is useful. Error messages can be very useful sometimes. But if you give a lot of information about the internals of an application, then you're opening up for attack. So you have to be careful there. Okay. But yes, Puneet, I think looking at inspect editor and looking for error messages there is a very good way to find security vulnerabilities in applications. It is not that straightforward that you just look at inspect editor and if you find an error message, you'll find a security vulnerability, but it's a starting point. Exactly. Exactly, Puneet. So, for example, let's say you understand that they're using MySQL version, I don't know, 4.x. Okay. And if you know that MySQL 4.x is a vulnerable version, that means now you can focus your effort of finding vulnerabilities in that area, right? So that's why error messages are important. Like I said again, I want to repeat again. While these techniques are very useful, you must only run this on applications where you have the permissions to find vulnerabilities, or on test applications. Okay, never ever do this to applications in general.
on the internet where you don't have permission to, perform a security testing. Okay, Abhishek, should we wait some more time or wrap it up?
Yeah, I think we'll just wait a minute more.
Sure.
In case something might come to somebody's mind and
Sure, sure.
so participants will wait for another minute. In case you have any questions, please put it in the chat box. And Sandesh would be quite happy to answer it.
Right. Yeah. So this error message does not give you anything dangerous, Puneet. If you do find anything, any security vulnerabilities on Razorpay, you can always report it on HackerOne. This is a good error message, in fact, because it tells you what policy was blocked. And CORS is an important security policy. It's called Cross Origin Reference. You can look it up. You should definitely Google CORS, and you'll understand why this error message came. Manoj, if you want to read more about cross-site scripting, I will give you a link from OWASP. Okay, which will, in fact, I spoke about the cheat sheet, right? There is a very good cheat sheet from OWASP on cross-site scripting. Let me see if I'll give you two different ones. One is from a company called Portswigger, which does a very good job of. So they build a really good tool called Burp Suite. So there is a cheat sheet for from them. So Manoj, you can look at that. And then there's another cheat sheet from OWASP, which talks about what are the different payloads you can use for XSS. Okay, the OWASP one is a little advanced, but you can look at that too if you're interested. When we create AWS account without debit card, I don't think so, Pooja. I'm not sure, but I don't think you can create AWS account without a card. There may be some ways of doing it, but honestly, not my area of expertise. You can do it with AWS credits, I think, but I think you still need a card. So I think here's an explanation. I'm just pasting in the chat, Pooja.
He had some query specific to the RuPay card.
I think the query is, why doesn't AWS accept RuPay card? It's a question for Amazon, Pooja. I don't really know. Let's see. Yeah, there's a list of all accepted payment things, and I don't see RuPay there. No, I think they do accept RuPay cards, but only RuPay credit cards. Putting in this list here. How can we report the website means how can we contact? So like I said, Mehboob, many companies have something called a vulnerability responsible disclosure policy. Okay, so many companies will have it on their website. You can go look at it, or what you can go to HackerOne, right, and then see if their company is listed on it, HackerOne or Backrot, etc. So that's the best way. The second way you can do that, if you don't find any information anywhere, is that see what social media handles they have, right? If they're either on Twitter or LinkedIn, etc., and reach out to them respectfully. Okay, don't say things like, oh, I've hacked your application and things like that. Respectfully reach out and say, hey, I may have found a security vulnerability, can you please reach out to me? Okay, most companies will have a security team who will reach out to you, but do it in a direct message or a private message. Don't do it on public. Okay, so option number one, go through their website and see if they have a vulnerability responsibility disclosure program and follow the guidelines. Option two, look at bug bounty programs like HackerOne, Bugcrowd, etc. Option three, reach out to them on social media in a respectful manner. Can you hear me, Abhishek?
Yeah, you're quite clear. I don't know what.
Okay, Mohammed, it may be on your side.
Yes, there's a question from Narayan asking about, can you walk them through a standard operating procedure?
Oh, I didn't see that. Standard operating procedure for what, Narayan?
Narayan, Sandesh would like to know standard operating procedure for what? Can you explain your question?
Anyway, I think we're coming up on time. So what I will do is that Narayan, you can reach out to me outside as well. I'll post my I'll give you my email address as well as my LinkedIn account here. If any of you have any questions or want to reach out to me, please feel free to do that. That's my LinkedIn. You can also reach out to me on my Gmail account if you want to write me an email. At any point, if you have any questions on application security, if you want to learn more about AppSec, if you want any guidance, please let me know. How does ISO 27000 PCI DSS and SOC 2 compliance affect application development? Okay, that's a good question. So PCI DSS and SOC 2 definitely does. Sorry, they have later in PCI DSS as well as in SOC 2, right? There are certain line items which specifically talk about secure application development and specifically talk about application security testing. Okay, so if you haven't done those processes and if you haven't taken those steps, then you will not be able to get those certifications. Right. So yeah, so security, application security is a critical part of PCI DSS and SOC 2. ISO 27000 not so much. There's a one line item there, that's all, because ISO 27000 focuses on many areas outside software as well. Okay, great. Abhishek, can we wrap it up here?
Yeah, I think that would be fine. I think you dealt with all the questions. We would like to thank Mr. Sandesh Anand, Senior Engineering Manager, Information Security, Razorpay Corporation, for this very engaging talk on application security. So he has provided an overview of the concept, and I think most importantly, Sandesh, what stands out in your talk is that you debunked a lot of popular myths, that we are taught that the MD5 algorithm is extremely robust in protecting our passwords and so on. And also the interesting point that you made about the router password. So a lot of people don't really pay attention to these little things which might turn out to be quite significant in the long run as far as cybersecurity is concerned.
True.
We'd like to thank you for this talk, and we hope that you come back on another Sangha Chadvam or career guidance webinar soon for CySec. And thank you for doing it in spite of your health not being at its peak. So that makes it all the more special.
Thank you for inviting me. I've always enjoyed, collaborating with CySec, and this was great as well. And thank you for all the great questions. I was very happy to see all this.
Yeah, I'm sure that's also a very important concept of, a very important component of this full webinar. So we thank all the participants who asked very interesting questions and made Sandesh juggle his mind while answering those. And Sandesh has left his contact coordinates. There is his LinkedIn address as well as his Gmail, which is anand.sandesh@gmail.com. So if any one of you finds any security vulnerabilities on the Razorpay website, make sure that you DM him immediately. So with that, we'd like to close. I will post the link for the assessment in just a moment. So thank you, Sandesh. If you
Thank
want, you can sign off now, I think.
All right. Thank you. Thanks, everyone. Thank you. Bye-bye.